Thanks. Oh, that's weird hearing my own voice. Welcome to my talk. It's about building real-time collaborative experiences with Flutter. And actually, the light title could have been building these experiences with Dart, because most of this stuff here is basically the Dart code, but only the UI layer here is kind of Flutter. And a bit of myself. I'm Eero. It's with two eyes. There's a common confusion, so I read my name in lowercase. I started a blog about Flutter that Dominic just mentioned. It was called flutter.rocks. That was the URL. And now it's just basically called eero.dev. And last 5 years, I've been doing Flutter professionally. I started in this Finnish company called CodeMate, or Ripple App Studio. And then I was a front-end lead at Reflectly, which was like this journaling app with a cute little mascot. And now I'm a principal engineer at Superlist. And Superlist is basically productivity tool for individuals and teams. We just launched like an open source website. Well, I mean, a collection of our open source packages with like SuperEditor, which is like a rich text editor for Flutter, and native extensions, which is like, it has full-featured clipboard, like a clipboard that you can put something else than just plain text to. And we have this really crazy drag and drop as well as a package, which works on macOS, Windows, Linux, iOS, Android, web, and on supported platforms, you can just drag stuff from some other app to a Flutter app and back, and it supports virtual files and all that stuff. And then we also have Super Audio, which is recording for audio and playing audio. And we're also hiring all the time. So if you find these challenges here interesting that you will find, just apply today, basically, I guess. And before we start, this is not a tutorial. It's more like companion talk for an open source repo that I'm going to share. Oh no, it's private actually right now. Well, I will make it public after the end of this talk. But basically, it's better if you read the code, use the code, and this talk as like a guide how to understand how all this stuff works. And let me share my screen to show what we're going to building. So here we have this Flutter web app. And this is like really, really, really basic version of SuperEditor. And you can type something. And you can, of course, there's a secret shortcut how to make text bold or italic. And then you can also undo changes. Oh no, that happened. Okay. I think it's fine now. It was just sleeping on the background, but okay. Again, so we can undo and redo stuff. And also you will see this users online counter here. So I will use my second laptop to do something else here. I edit A and something else. And now we can have like this laptop is A, another is B. Oh my God, no, now we have other people. Okay, let's have fun. That was the intention. So just type something, and yeah, I think this will break at some point, and that will be expected. Let's see how many users it takes to break. But basically, you can still undo and redo while you guys are like typing stuff there. And yeah. 10 users and still PC. Like it's no, I mean everything is correct. Nobody's doing something nasty, which is nice, and that's why my cursor is over the X here. I guess we're not able to break it. We have 16 users now, 17, 18, 19, 20. Okay, but that's the demo basically, and this is what we're gonna build in the next slides. And I'm gonna run this demo down after this talk. You will not be able to do anything anymore. Okay, that's the demo. And yes, it worked. Yeah, cool. And basically, by the way, that's not Superlist. That's not the app that we have been building for the past 2 years. It was just like a really, really, really simple demo. And let's go over how we ended up here building this collaborating experience. And first, Superlist was basically like a task management app. We had like tasks that you could complete and assign to other people and stuff. And just like a regular task management app, it still is. But 1 year ago, we wanted to build something like this, what we called initially document mode, which is like this rich text editor kind of experience, but with some tasks embedded inside of that editor so that you could do task management within the context of a rich text document. And yeah, like we were like, okay, how do we do this? Do we just go to Bob and import document mode? No, we go to Bob and we import SuperEditor because we had been building this with Carol from pretty much from the start of Superlist. And SuperEditor is basically like a rich text editor for Flutter that has all kinds of, it's extensible, it's pluggable, you can have all kinds of custom components and stuff. For example, we have those tasks in the document, but you might have something else. Maybe you need some, I don't know, like an offline dinosaur game in your document or something. Well, you can do that with SuperEditor. And basically, we had a working proof of concept in 4 days with SuperEditor, look kind of like this. So we were able to do these headings, subheadings, and of course you can make stuff bold and italics. It's not showcased in this demo because I forgot. And then you could add some simple tasks to a document. You could check them off, and you can assign a task to somebody, and you can also reorder stuff by drag and drop, which was kind of cool here. And oh yeah, those documents also had to be shareable to other users so that I can have a document, I share it with somebody else, and we should be able to collaborate on it, or at least edit the same document. And at first, we just said that, you know what, it's going to be okay if we don't do the most advanced and hardest thing ever, which is like document like real-time collaboration with all this fancy stuff. So we had like FCM to broadcast changes to every client. We were sending the whole document on each change, even if one character changes. And of course, we were debouncing this, otherwise it would be kind of crazy. And we basically said that, you know what, if we just do last write wins, that will be good enough. Like, we'll not need to do something more advanced for now, maybe for a year or something. But that was not the case. Here's an example of 2 clients with this last write last write wins kind of thing, where on the left somebody's typing something, and on the right client is kind of overriding what the left client is doing. We also had some other problems, like if I'm trying to type something, my cursor would be jumping around while other users edit the document. I would lose quite a lot of progress, just like you saw on the previous example. And oftentimes, we would end up in completely different document states. So like user A has a different document than user B. And more users you had, it was kind of, yeah, not good. We were thinking like, maybe there's a better way. And Also, meantime, our design team got a little bit crazy. It was like, we want to have this actually, which is like you display some person that is typing right now, and then like all this other stuff. So yeah, something like this is kind of today. It's not nice to have this advanced kind of collaboration, but it's more like expected. Users expect it, and they will notice if it's not there. But we have this problem that SuperEditor doesn't take any stances on what is collaboration. It also would be kind of disruptive to other clients of SuperEditor, because there was other apps using it, that we would just make this opinionated that, hey, you know what, we're going to store SuperEditor documents this way, and you just have to do it the same way as we are doing, because people don't always agree that was the best way to do this. And we just wanted to keep SuperEditor really like, it has no opinions how to store something, how to do this collaboration and then everything. So, but we still had the problem that Superlist needed kind of this collaboration features now. And here's an amazing picture of what we needed. So like we have SuperEditor, then we have our backend, and in the middle, we needed to have some kind of magic collaboration layer, TM, that would resolve this stuff so that we can type with multiple users in the same document. And here's kind of how it went down. And we were looking at, okay, what are the common ways to do this? One of them is called operational transformation. And the other one is conflict-free replicated data types, or OT and CRDTs. And we went with the operational transformation. It seemed to have more history with rich text editing. I mean, in JS world, there are like some editors that do CRDT, but yeah, we didn't have experience with OT or CRDTs, so we were like, okay, let's pick one and go with this one. So now that we made the choice, how do we actually implement it? It's not like it's not the simplest thing to do, actually. Well, there's a simple answer, actually. You just read a lot of research papers. So what I did next, I went to Wikipedia, and I went through 30 articles. And once you actually get through it, for example, here's the first bullet point. Just scan HP from left to right to find the first operation, and so on. Like, after reading that and all this stuff here, all became quite clear, and then we were ready to implement this whole thing. Well, that's not what actually happened. I come from a cooking background, so I lose focus. If I'm reading a recipe, I sleep in the halfway in the middle. So we didn't do that. I actually found an end-to-end example, and it had backend written in Elixir, and frontend was JavaScript, and it worked. It was like really stripped down, but it worked. So there was also a talk, companion talk to that repo. That helped a lot. No need to read all the research papers. And I kind of then, what I did, I ported the JavaScript code to Dart and made it work with SuperEditor. And here's the journey, kind of. Here's the parts that go into it. And it's a lot of slides and a lot of code. Let's try to get through them. Yeah, and this is what we think worked. It worked for us, probably works for you as well, but it's not the only way. But what helped really much is using the quell delta format. It's a library, and original reference implementation is done with JavaScript, but it's ported to Dart. It's a really nice library, actually. And it contains like functionality so that you can express changes in the documents nicely, and then it contains utility methods how to then kind of transform some document to another, and so on and so on. We will go through over this stuff. And what it basically is like a fancy list of map structures that can be expressed as JSON. But the benefit of using this library is that you can construct those map structures in a type-safe way. And also, like I said, the library contains utility methods so that you can do diffs and all that stuff that is usually very useful when you're doing these things. So how do we express document in this weird delta format? And what we do is like document deltas, they only contain insert operations, nothing else. So here's an sample. It has 3 paragraphs of text and 1 image in the end of Brent Rambo. And that's how you would do that. And then, of course, you have to pass this delta to your editor and render it some way. But we're just talking about how data flows here. Here's another example. You can have a paragraph with attributes. So at first, there's like a paragraph with bold text and italic text as well. And then we added alt text to the image so that other people can also join the fun of seeing what brentrambo.gif actually means. And you can also have multiple attributes on the same piece of text, basically. So if you want to make one run of text bold and italic at the same time, you just add those attributes to that text. And yeah, basically there's no right way or wrong way to do these attributes. So you have to just be like, okay, well, for us, bold means that the key bold equals true, and the key italics equals true, but you can have whatever. You can even have it in Finnish or Estonian if you want, it's fine. And if you want to do something really custom, that's fine. You just have to define what this example would mean in UI terms. Just render a unicorn that has rainbows coming out of the backend. So now that we have a document delta, how do we perform a change to it? That's where we use change deltas. And well, it might be a little bit confusing because documents are deltas, but changes are also deltas. So everything is delta. But the difference here is that change deltas can contain insert, retain, and delete operations, but documents only contain inserts. If a document contains anything else than inserts, then it's like you cannot just pass it to an editor and be like, oh, what is retain? What is delete? And here's a basic example of a change delta. And we can run through it line by line. So we have retain. That's one type of operation. What it means is like you just skip over the 6 first characters in the document. And then we have an insert operation as well. That is, it inserts the text that you provide to it to the current position. And at this point, the current position is 6. And then we have delete operation. You pass it an integer, how many following characters you want to delete. So, and also you might have noticed that there was no document there. That was like, oh, well, it's a change, but change on what? Here's where like this delta.compose method comes in. So if you have a document A with the contents hello world, we want to change it to hello people. Here's how we do it. So here's the document, hello world. We want to change it to hello people. So this is the exact delta that you saw. So what we do, first we say retain 6, which means skip over the word hello and the space that comes after it. Then insert the text people at current position. And at this point, the document will be hello people world. And then we delete the next 5 characters. And once we compose this change, we say hello world that compose the change that we had. Then we have the document that is in the comment. So now we have hello people. And now we get to the juicy parts. And we'll have a simple example how this stuff works. But this stuff is not actually that simple. I'm trying to explain it in a simple way. So let's see how it works. So this is kind of how the sync logic works. If you have so you have a server. It's a central server. It tracks what version the document is currently. Same for every client that is connected. Client A and client B has the document version 0. And now client A made a change. It wants to insert ABC. So it tells the server that, hey, you know what, server, please apply this operation on your server document, which is insert ABC at the start. And it also sends version 0 with the change so that the server knows that, okay, we need to make this change, but this change is made on a document that has the version 0. But the good thing here is that the server version of the document is also 0, so we can just use the compose method that we had, and the delta will be empty because the document is empty. We just say delta.compose, insert that, and then the server version will be 1 with this contents, and the client A also bumps the version, and now client A and server is up to date. But the problem is client B has a quite bad connection. They're actually on a vacation in Mars, so it takes a lot of time to get the changes there. So what happens here? So client B is still at version 0. Now they insert 1, 2, 3 because they wanted to. Then they tell the server that, hey, you know what? We want to make this change on the document version 0, insert 1, 2, 3. But now, at this point, the client B gets the original change from client A. That's not the problem. It can actually apply it by saying compose. So this will be the version will be incremented, and now the document version in the client B will be ABC 1, 2, 3. But then we have this weird change that we are trying to apply on the server. But the server version is 1, and this is like trying to apply some change on a document version 0. So how does the server, what do we do with this? And the solution, this is the problem. The incoming change that client B sends is operating on the older version of the document. Solution is server will bring that change up to date so that it knows how to apply it. And how does the server does it? It does it with this utility method, again, called delta.transform. And this can be used to bring an out-of-date change up to date. So if you have two documents, two changes, sorry. We have change A, which reads the server first, and then we have change B. How do we make it up to date? Well, we say A.transform B, which will then, it's a little bit complicated what happens behind the scenes, but then we get B up to date. And this true flag here is basically just like, it says that A takes priority over B, so that if there's a conflict, A wins, which happens here that, now we have a transformed change that is skipping over the ABC with the retain 3 operation, and then it's gonna insert 1, 2, 3 after the ABC, which becomes ABC 1, 2, 3. It's actually more complicated than that, and it's actually even more complicated than that. But you know what? It's gonna be in the sample app. And also, one key part here is also that the server always stores every change that happens to the document. Otherwise, it cannot know how to bring these changes up to date. Yeah, and it's more complicated than that. Will be in the sample app. But okay, so here's what actually will happen. So we do this. We have this delta, the transform magic box here. And because server already knows that one change, knows that the document is APC on the server side, we put this change into the magic box, and we just call delta transform on it. And then we bump the version on client B to version 2. And now client B actually has the most up-to-date correct document state. And now we have to bring server and client A up to date. So we transform this change into what it actually should be. It should be retain 3, so skip over ABC, and then insert 1, 2, 3 in the current position, which will look like this. And then we have document with the version 2 and contents of ABC 1, 2, 3. Then we can tell client A about it. It will compose this change and bump the version, and now everybody's up to date. And that's like one of the million ways that this config resolution works. I mean, it works the same way, but this is just one scenario how it helps. There's a lot of different weird scenarios that I could present, but this is just one. And you might think that, okay, the server must be insanely complicated. Well, here's something. I'm not sure if it's even visible. Oh, it is good. So this is what you already know. The server stores the contents of the current document and version. It also always stores each change that happened on the document on every time that some client applies a change or sends that to the server. So then we have this logic where we figure out how far behind the client version is. So if client version is like, let's say it's 0 and server version is 1, then the change count will be equal to 1. So the client is behind 1 change. And then we take like, yeah, this is a little bit crazy, but we take the list of changes. We kind of start with the client change, which is going to be out of date. And then we just like apply or like transform the client change with every single change that the client change has missed. We get the up-to-date change, and then we update the server state and we bump the version, and we always have to just add that change to the change log. Otherwise, we will not know how to bring changes up to date. Here's the entire code for this simple server. We are not going over the WebSockets. We don't have time. I think we're already I need to speed up almost. Yeah, we actually use Elixir, not Dart, but it's a Flutter conference, not an Elixir conference. So I try to explain it with Dart. This code doesn't have error handling, and it doesn't prevent clients from corrupting documents, which is a good idea to do. Usually that will not happen if you implement correctly, but it's good idea still. Okay, now we get to the sync logic on the front-end side. We have this class we call document sync engine. It knows how to do the front-end part. So there's like this document channel. It's like a helper class kind of that helps us to send something to the server, but also when server gets new changes from other clients, we will get notification of that as well. Then we store the current version and current document contents in the sync engine as well. And here's what happens when we first open a document. So we join the channel and we have these callbacks that we register. So if when the server responds that, okay, document was correctly opened and stuff, then we get these callbacks. And same for if some other user changes the document. So this is what happens when the document is opened. We basically get what is the server version of the document, what is the server contents of the document, and then we update internal state. And on the last line here, we just tell SuperEditor that, hey, here's an entire document that you should now render. And when another user, when our user, we edit the document, then we have something like this. We pass it the whole document, and then we do a diff. So we figure out what is actually the minimal change, and we can do so with the delta diff method, which is kind of answers this question: what is the most minimal change from hello world to hello people? And we already know what the change is going to be. It's this one that you already saw, but we basically say a.diff b, and we get what the change is going to be. What's the difference between these two? And if we say a.compose, the diff between a and b will land to b, basically. And let's get back to this one. So, okay, we say change something in the document, then we do a diff. We make sure that the diff is not empty, because if it is, there's no change between the two documents. So there's nothing to send to the server. And then we have this piece of code. So for example, we update the internal document state again by saying compose. And then we send the change to the server and bump the version internally. And it's a little bit more involved, actually. There's a lot of stuff here. Don't care about this one. It will be in the example. It will be commented, and it's even more complicated than that. What happens if somebody other user edits the document? Well, we have this callback here. So what we do is the same thing. We compose the current document with the change, so we get the new state. And then we pump the version, and we tell SuperEditor that, hey, here's the entire document that you now have to re-render. It's more complicated than that, of course, and it's even more complicated than this, but we are not going to have time for that. And now we have consistent data flow, and we know how to resolve conflicts. Are we all done? Can we now finally go to sleep? Nope, we have to do one other thing, which is transforming document selections. So here we have an example without selection transformation. So what we want to do on the right side, the client is not doing anything. They just keep the cursor behind the character F, but somebody adds something in front of their selection, and it's just like shifts like this. We don't want that. Otherwise, we just add characters to random positions. So we need this selection transformation. And here's what we have delta transform position for. And it answers this question. We have an outdated offset. Give me the updated offset based on the change that will happen. So if we have this is a collapse selection after the letter F. This is the alt selection. Then we get this remote change. Somebody inserts 4 X's before or at the start of the document. Then we can just say remote change the transform position, and we pass it the selection start and selection end from the old selection. And then we get a new selection, and we tell the editor that, hey, you know what? Update the selection with this one. And we run this every time somebody makes a change remotely to the document. And here's the happy smileys that like this is with the selection transformation. The right user is now happy, and they can just type whenever, and their cursor will just not be in random positions. Let's see if we have time to run to, this is going to be a speed run of undo redo. Let's see. We want to have undo redo, and we have this class called simple local document history because it's very simple and it's local document history. Okay, so at this point, we have document state ABCX. So like every time we make a change to the document, we tell the history that, hey, compose local change, blah, blah, blah. So we will have like this, and if we want to undo this specific change here, we want to remove the X because that was the last thing that we did. We want to get this change back from the history. We say history undo, and it will give us the change. And if we compose that change on our document, it should then be an undo action. and same for redo, basically. And yeah, then we have a bunch of code here. I don't know, it's a lot of code. I'll try to show basically the basic thing that we need to do here. So we have undo stack, we have redo stack. Every time the client does changes on the document, we add something to the undo stack, but we need to add an inverted version of that change to the undo stack. And what is an inverted version of that? Let's speed run to that. There's this utility method called delta.invert, which kind of gives us like, okay, what's the complete opposite of this change? So if we have this document hello world, we have a change that makes the document into hello people. We can say change.invert, and then we get this. So we get something that, so this will bring hello people back to hello world. And okay, so back to the example. Every time user makes a change in the document, we tell the history that composed this local change, add an inverted version of that to the undo stack. Then we clear the redo stack, because that's how undo redo works from user perspective. Then we bring the document up to date. So now we want to undo something. We remove the last entry from the undo stack. We put inverted version of that to the redo stack. And then we bring our internal document state up to date. Then we return this change so that the client of this class knows they can just compose this change on their document, and then that's kind of undo. And redo is pretty much the same, but we just remove from redo stack, we invert that change again, put it to the undo stack, and otherwise it's the same thing. We return that change, and the client of this class can then compose the change on their document to have a redo action. And yes, there's also one missing piece here. I feel like I don't have time for this. I'll try to speed run, but what if I have changes in my undo, redo history, and some other user edits the document? What will happen? My undo, redo history will be operating on an outdated document. So I'll try to illustrate this really fast. So it's exactly the same, but remote user, they delete A from the start. Now we have document PCX. Now this undo and redo will be completely outdated and working on some weird version of the document that nobody knows what it is. So every time a remote change happens, we need to actually tell the local document history that, okay, the document has changed, which will then bring it up to date. And here's how we do it. We have this another method called compose remote change. And there's going to be a magic inside that then brings undo and redo stacks up to date. And the magic will looks like this. We will not step through this one line by line, but delta the transform helps here as well. So the piece that we saw with the server, the sync logic example in the beginning, and that's undo redo. It has some caveats. You can pause and read this. Are we done now? We have to also, so now we have this collaboration magic layer, but then there's some parts here that we need to wire up for SuperEditor. So one of them is like, we need to convert this delta document into a SuperEditor document so that SuperEditor can render this whole document. And also we need to do that back. And then we need to kind of, the selection transformation needs to be done in SuperEditor specific way. There's an example in the source code. How do we do it, tie it together? So like every time a remote document changes, so other users are editing, then we convert the delta document to SuperEditor document. Then we execute this SuperEditor thing that replaces the SuperEditor document with the new document completely. And every time we do changes that we change something in the editor, we also need to transform the selection at one go. And yeah, okay, the demo worked. Yeah, I had a reminder here. Then there are also challenges like debugging and testing on two computers. It's annoying. Yeah, I mean, you can ask about this later, or I'll make a blog post or something. Of course, there's also further optimizations that you could do. Like now we're sending every keystroke, but no, that's not the best way. So we will group the changes and stuff. And yeah, thanks. we finished it.
Yeah.